Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P16F3 signifies a low voltage issue within the starter cut relay 1 control circuit in a Honda CRV from 2017 to 2022. This code is part of the Powertrain Control Module, PCM, diagnostics related to the fuel injection system, PGM-FI. The starter cut relay plays a crucial role in the vehicle's starting system. It prevents the engine from starting under certain conditions to ensure safety and proper vehicle functionality. When the vehicle's ignition is activated, but the engine doesn't crank, this relay is often one of the first components to be investigated for faults. In this case, the DTC indicates that there might be insufficient voltage reaching the relay, hence preventing the engine from starting effectively. The starter cut relay 1 is an essential component of the vehicle's electrical system that is primarily responsible for controlling the engine's starting function. Its role is to act as a switch that either allows or prevents the flow of electrical current necessary for starting the engine. This relay operates based on inputs received from the PCM, which relies on various sensors to determine if the engine can safely start. The relay is usually located on the relay circuit board, which is situated under the dashboard of the vehicle. In effect, if the PCM detects conditions that could lead to engine damage or safety hazards, it sends a signal to the starter cut relay to prevent the engine from cranking. Thus, a fault indicated by DTC P16F3 should be diagnosed promptly to avoid further complications. Various factors could lead to the DTC P16F3 being set. A commonly suspected issue is its faulty starter cut relay, which may have developed a circuit malfunction over time. This could include corrosion, wear, or internal failure that prevents it from operating correctly. Additionally, wiring issues such as shorts, opens, or loose connections can disrupt the voltage supply to the relay, resulting in the low voltage condition reported by the DTC. Finally, there's the possibility of a malfunctioning powertrain control module, PCM, itself. If the PCM is not functioning properly, it may fail to send the correct signals to the starter cut relay, leading to low voltage conditions. When the DTC P16F3 occurs, you may encounter several symptoms that indicate a potential issue with the starter cut relay. The most notable symptom is that the engine fails to start. When you turn the ignition key, the dashboard may display warning lights like the check engine light, yet there is no response from the engine. Often, you will not hear any cranking noise, which usually accompanies a failed start. You may also notice irregularities in the electrical systems functioning within the vehicle, as the starter cut relay can influence multiple components. As a safety measure, the vehicle may lock out the starting system entirely until the condition is resolved. The first step in troubleshooting DTC P16F3 involves performing an engine starting check. Begin by attempting to start the engine. If the engine starts, proceed to the next step in the diagnostic process. If the engine does not start, move to step 4 for further analysis. This initial check is crucial in determining whether the issue is an immediate starting problem or related to the starter cut relay. A successful start suggests that the starter cut relay may not be the primary fault, while failure to start indicates that further troubleshooting is necessary. It sets the baseline for identifying whether the DTC is a symptom of a larger problem. The second step is to verify the problem by toggling the vehicle to the off lock mode and then to the on mode. This cycle helps reset various systems connected to the relay, aiding in a comprehensive diagnostic process. Next, clear the DTC using the Honda Diagnostics System, HDS, which is a specialized tool designed for diagnostics and repairs on Honda vehicles. After clearing the code, check for any pending or confirmed DTCs once again with the HDS. If DTC P16F3 reappears, this confirms that the failure is consistent and should prompt the technician to continue troubleshooting. Alternatively, if the code does not return, it may indicate an intermittent issue worth further inspection for poor connections or loose terminals. For the third step, focus on checking for shorted wires in the starter cut relay circuit. Begin by ensuring that the vehicle is in the off lock mode. Then use the HDS to jump the SCS line and wait for more than 1 minute before proceeding. Next, disconnect two critical connectors, the PCM connector A and the relay circuit board connector A. This disconnection is essential for running continuity tests without interference from other circuits. After disconnecting, check for continuity between the specified test points, pin 15 of the PCM connector and the body ground. If continuity is present, it indicates a short in the ST-cut RL1CL wire and necessitates repairs. If not, the wire itself may be intact, and further investigation into the PCM or circuit board might be required. In the fourth troubleshooting step, focus on determining the area of potential failure. Start by ensuring that the vehicle is in the off lock mode. Once again, use the HDS to jump the SCS line and wait more than 1 minute. After this, disconnect the PCM connector A. Switch the vehicle to the on mode to enable measurement of voltage across test points 1 and 2. These points are specifically the PCM connector pin 15 and the body ground. If you measure battery voltage, it suggests that the wiring is functional and shifts attention to the PCM, which might be defective. If battery voltage is absent, this could indicate an open circuit type fault. Either an issue exists within the circuit wiring or at the relay board itself, requiring further examination. The fifth step requires examining for open wires in the ST-cut RLY1CL circuit. Begin by turning the vehicle to the off lock mode again. Disconnect the relay circuit board connector A to isolate the circuit path. Next, you need to check continuity between specified test points in the circuit, particularly between pin 5 of the relay circuit board connector A and pin 15 of the PCM connector A. It's essential to perform this test with both connectors disconnected to ensure there is no influence from other components. If continuity exists, the wire is intact, and you can proceed to the next step. However, if continuity is not established, it points towards an open circuit, which will need to be repaired to restore functionality. For step 6, you will conduct a fuse check to ensure that the fuses controlling the circuit components are intact. Specifically, check fuse number D20, rated at 10A, which is located in the under-dash fuse relay box. A blown fuse can lead to the circuit failing to deliver the necessary voltage to the relay, thereby causing the issue represented by DTC P16F3. If the fuse is functional, proceed to the next step in troubleshooting. On the other hand, if the fuse is blown, this indicates a potential short in the IG1 starter cut wire and will require further examination and repair of the wiring, alongside replacing the blown fuse to ensure that the circuit is restored properly. In the final step, perform another open wire check, this time focusing on the IG1 starter cut line. Disconnect the under-dash fuse/relay box connector C and the relay circuit board connector B to isolate the circuit for testing. You will also connect terminals A and B with a jumper wire to ensure that the circuit is complete for continuity testing. Specifically, you will check continuity at test point 1 of the relay circuit board connector B and body ground. If continuity is present, the IG1 starter cut wire is in good condition. Conversely, if there is no continuity, this indicates an open wire issue between the under-dash fuse/relay box and the relay circuit board, which must be repaired to ensure the correct functionality of the vehicle's starter circuit. Upon completing the necessary repairs based on the troubleshooting steps, it's vital to conduct a final verification of the repairs. Start by double-checking to ensure that all work performed is complete and correctly reassembled. Following repairs, clear the DTC using the Honda Diagnostics System, HDS, to reset the vehicle's onboard computer. After clearing the code, a road test should be performed to ensure the vehicle starts without issues and operates normally under standard driving conditions. Pay attention to any warning lights that may reactivate, signaling unresolved issues. If everything operates as expected, you can confirm that the repairs addressed the DTC P16F3 effectively. To prevent issues such as DTC P16F3 from occurring in the future, regular maintenance is paramount. Schedule routine checks of the vehicle's electrical system, which will allow for early detection of potential faults. Inspect the starter cut relay's function periodically to confirm it operates as intended. It's important to ensure clean and secure connections, particularly at the relay circuit board and PCM. Corrosion or loose connections can lead to voltage drops and operational failures. By staying proactive with these checks and maintenance practices, you can help prolong the lifespan of the starter cut relay and improve the overall reliability of your Honda CRV. In summary, understanding and addressing DTC P16F3 involves careful diagnostics and an organized troubleshooting process focused on the starter cut relay and associated circuits. Key components such as the PCM, wiring, and potential faults like blown fuses or poor connections should be assessed meticulously. By following the outlined steps, you can accurately identify and rectify the underlying issues affecting the starter cut relay system. Furthermore, maintaining a routine inspection schedule for electrical components will help you address root causes before they escalate into more significant problems. Lastly, effective use of the Honda Diagnostics System, HDS, has proven vital in confirming repairs and ensuring a reliable maintenance routine. Please like and subscribe to the channel. See you next time.